So we've looked at examples of graphs where the domain and the range are, the domain and or range are kind of naturally limited. But you have something like a straight line, and typically, the domain and the range of a straight line, most of the time, okay, a lot of the time, is unrestricted. So if you look anywhere on the input, the graph exists. There's no point at which the graph ceases to exist. There's no input that y is equal to mx plus c is inherently allergic to, And likewise, if you look at the outputs, right? So outputs, we're looking at y, and we see that again, the straight line spans the full range of y values. If you think of any y value, there is some input that is yielding that particular y value. So the range of a straight line really is the whole spectrum of real numbers. Wait, that went in the wrong direction. Right, so a straight line in and of itself typically does not have a restricted domain or range, but there are some scenarios where it makes sense to restrict either the domain or the range of a particular linear function. So, I'll give you a silly example. Let's say, for instance, right, so let's just say this is some crazy scenario. My parents started giving me pocket money when I was 6 years old, and they'd give me 5 Rand a week. And then on every birthday, they would increase it by 2 Rand. This went on until I turned 18 and left the house. So let's figure out, how we would represent this graphically. So in terms of the function itself, here's what's going on. When I'm 6, I get 5 Rand a week. When I'm 7, that goes up to 7 Rand. When I'm 8, that goes up to 9 Rand. When I'm 9, that goes up to 11 Rand. So we're going up in multiples of 2, so that gives me the sense that, okay, my function is y is equal to 2 times some input. And if I look at this input-output pair, for instance, 2 times 6 is 12. To get back to 5, I'd need to minus 7. So y is equal to 2x minus 7. Let's test it with this input-output pair. 2 times 7 is 14, minus 7 is 7. That works. 2 times 8 is 16, minus 7 is 9. So that right there is a function that is telling me, for however old I am, my age is my input, then this is the pocket money that I am getting. And so, we could very naively just go along then and plot the graph of this function. You could find the x and the y-intercept, so we know that the y-intercept is going to be -7. Okay, I don't have that in view, so maybe let me change my axes. So my y-intercept is going to be, okay, it's going to be over there, right, at -7. And then my x-intercept is where y is equal to 0. If you solve that, you should get 3.5. So my x-intercept would be somewhere over there. And so the line that I would draw roughly, oh my gosh, this is so stressful. Alright, and so it would go. Alright, and that hypothetically would be a graph that represents this function. However, given this context, the context of our problem, this graph doesn't completely make sense, because what we'd then be saying is that, there's a point at which I have a negative age, and my parents are not giving me pocket money, but instead I am giving them the pocket money because the output of my function is negative. It would also be defying what the context has told us, that the pocket money giving didn't just begin the beginning of time, it began specifically when I was 6. So over here, right, when my input is 6. So this is where, oh dear, it has moved. The pocket money giving began. And, when I was 6 years old, I got 5 Rand. So really, all of this is not relevant to the current context because it began here. And then the other important thing is that it doesn't go on indefinitely until, I'm infinitely many years old. It stops when I'm 18 years old. So the correct graph to represent this function, well, this context rather, would be, right, the money giving began when I was 6 and I got 5 Rand. So that would be the first point. And we color it in to show that we are including 6 in our domain. So if it was an open dot, then we'd say that we're not including 6 in our domain. The domain is any number that's bigger than 6, but not including 6. And then, of course, it ends when I turn 18. And I mean, the context is debatable. So do I still get pocket money when I'm 18? Or, anyway, so let's just assume that 18 is included. And the pocket money then is 2 times 18 minus 7, which gives you 29. I don't know if I have enough blocks. 5, 10, 15. No, I don't. So it would be somewhere up there. And then what you would do is you would join those two, and that would be the straight line function that represents this context. So that's what we call sketching a line with a restricted domain. So it's not a line that's just going infinitely this way and infinitely that way, because then the domain is unrestricted. Sometimes it's going to make sense to need to restrict the domain of your function, and so this is how you'd go about drawing a sketch of that function. And so the key thing is you just need to work out the coordinates of your endpoints, and you need to pay attention in your question whether they tell you that, so they might tell you that the domain is numbers from 6 but not including 6 up to 18 and including 18. And so if that was the case, you still work out your endpoint, but instead of coloring your endpoint in, you would make sure that your endpoint is a hollow circle. That indicates that that particular input-output pair is not included, and then the colored in circle indicates that that input-output pair is included. So much like when you did representations of inequalities on number lines, it's that same kind of logic. Alright, so this is a possible question you might be asked. Sketch the function y is equal to 3x minus 8 on the restricted domain. Well, they wouldn't say that. They would say x is an element of the interval from 1 but not including 1 up until 5 and including 5. And so, here's our x and y axes. Again, start by calculating what your endpoints are going to be. So when x is equal to 1, y is equal to 3 times 1 minus 8, which would be negative 5. So your one endpoint is going to be 1 and negative 5. And then next, when x is equal to 5, y is equal to 3 times 5 minus 8, which would be equal to 7. So your other endpoint is going to be 5 and 7. So you're going to have here 1 and negative 5. So let's just say somewhere here. and then you're going to have 5 and 7. So your graph is going to look something like that. And you would label those points with their coordinates, just for good measure. And of course, then you need to figure out what that x-intercept is. So take a pause and try to figure out what that x-intercept is. So remember, x-intercept occurs where y is equal to 0. So which input is going to give me an output of 0? So 3x would need to be equal to 8, and x would be 8 over 3, or 2 2/3. So those would be the coordinates of your x-intercept there. And that, in a nutshell, is how to sketch a function on a restricted domain. Calculate what the coordinates of your endpoints are, and then if it is cutting the x-axis at any point or the y-axis, then you need to also work out what those intercepts would be.